Hello, good afternoon. How are you today? Let's go with our second set of activities review, chemical reactions problems. So today I just sent a couple of hours ago the second activity. I ask you to have your calculator ready. Okay, we're going to need it. We'll do the problems now, so you don't have to work this evening or this afternoon, and you will have the spare time this evening and tomorrow. Okay, so let's take a review. Remember the beginning of the lesson: conversion from number of molecules, number of atoms, whatever, okay, number. So from molecules, atoms, apols, eggs, whatever, we can calculate the number of moles, okay, and using the Avogadro's number, Na, okay, 10 to 23, this big number. We convert from molecules to moles, and from moles to molecules. Now we know that the weight, the mass of a mole, and we can obtain the mass in grams using the molar mass. So for each substance, we have here a table with the different atomic mass. The molar mass is the same, but in different units, in grams per mole. Okay, so that's something you have to remember, how to convert from number of molecules to number of moles and molar mass. Molar mass, the mass of a mole, okay? Atomic mass, the mass of an atom. So let's go today. What's the path? Path, sendero, camino, path, okay? I said to Miguel, Ruben, and Raquel, since they are going to science, that the path is not easy. You're going to study more than your friends in letters, in society and social science, or so you have to be ready to work hard, but as I said, the bigger reward, la recompensa, the bigger reward. Let's go. Okay, first activity, take your calculator. Let's try. Was the mass in grams of 0.802 mole of C7H6O3. It's salicylic acid. It's a compound used for headache or different diseases. Acetyl salicylic acid. Acetyl salicylic acid. Okay, so first we're going to calculate the mass in grams. So we need something. Here you have the table. You can find in the table that carbon is 12, hydrogen is 1, and oxygen is 16 atomic mass units. So let's go, let's try. What would you do? What would you do? Okay, this is a review. So what is the mass in grams of, we know the mass, mole, we need to convert from mole to mass in grams. Come on, let's go. I'm going to do it very, very fast. So you have time to do it. First, I need to calculate the molar mass, okay? I calculate the molar mass of salicylic acid. Let's try to calculate, okay? 7, 12 times 7 plus 6 times 1 plus 3 times 16 is 03. Weight 138 grams per mole. So now I'm ready to calculate the mass in grams of this mole. Okay, what is your result? Tell me your result. Have you tried? Come on, let's go. Paula Gori, mole. Sometimes I write here mole of nitrogen, mole of. In this case, only one substance, so I don't need to write I don't need to specify the amount, okay? Maria and Paula Gori, 1 mole is 138, weight 138 grams. So let's go 0.102 divided 132. Oops, my mistake. Mole up and mole down, okay? 1 mole, 138 grams. You were right, okay? That's why it's useful to use this method, because, yes, you got it, mole and mole, so I can be sure that mole and mole, beep, beep, okay? So you got it, 111, 32 grams, the solution, the mass of this mole, okay? Number 1, very easy. Number 2, there is a mistake here. 180 grams of glucose, okay? Grams is missing. And how many? How is missing too? Okay, I wrote it too fast, too furious, and too wrong. Okay, 180 grams of glucose, C6H12O6. The molar mass is, let's go. They are asking how many molecules. So we go from grams, we calculate the moles, and we calculate the molecules. The molar mass is 6 times 12 plus 12 plus 6 times 16 equal to 118. 118 grams per mole. So we calculate the number of moles. We have 180, got it? Grams. 1 mole, 180 grams. So very easy. We have 1 mole. I give you all the constant you need here at the beginning. The Avogadro's number and the ideal gas constant. Okay, so how many molecules? 1 mole, perfect, Paula? We calculate the number of molecules. One mole, we know 6,022 tends to 23 molecules in 1 mole. So P must go away and we obtain 6.022 tends to 23 molecules. Okay? And the question, how many atoms of carbon? How many atoms of carbon? That's the difficult. In 1 molecule, there are 6 atoms of carbon. How do I know it? Look into the formula, okay? Look into the formula. We have in 1 molecule 6 atoms of carbon. So the number of atoms of carbon in this number of molecules, 22 tends to 23 molecules. There are 6 atoms of carbon for 1 molecule. So six times the Avogadro number, 6.022 tends to 23. We have 361 tends to 24 atoms of carbon. Okay, this is not difficult. It's calculate number of moles, number of molecules, and we know that with the formula the number of atoms of each element. Of oxygen, same number, okay? And hydrogen, 12, so double. Do you understand this type of problem? Easy, difficult? You need to understand this, you need to do this fast, and you need to have this concept clear to continue to do the last type of activities. Any question? No? Is this part easy? Is this part clear? Yes, Ruben got it. Vanessa, Claudia, did you got it? Miguel? Okay, if you understand, let's prove it. Come on, with problem number 3. What is the mass of a single sulfuric, how do I pronounce sulfuric or sulfuric? Let's listen. Okay. Let's try. I need sulfuric word reference. Let's listen to the pronunciation. Okay, sulfuric. No, I don't have pronunciation. Sulfuric. Yeah, sulfuric acid. Not sulfuric, but sulfuric acid. Okay, let's go. Come on, let's do the activity. What is the mass of a single sulfuric acid? Sulfuric. So balance of sulfur is 6. So 2 hydrogen, 6 plus 2 equal to 8 divided 2. Okay, let's try. What is the mass of a single sulfuric acid? Molecule. One molecule, okay? We need to calculate first the molar mass. Mass is 2 plus 32 plus 4 times 16 equal to 98 grams per mole. So how do I calculate this? We're in molecule, go to mole, and from mole to grams. Okay, you have 3 minutes. Come on. 3 minutes. Tick tock, tick tock. 3 minutes to calculate it. Come on, let's try. I'm going to use a clock. Okay. Do I have a clock? Online watch. Online watch. Let's go. Three minutes is it's okay, eh? You know. Let's go. Come on. 3 minutes is too much. Let's try in 2 minutes. Come on. One single molecule. One molecule. Okay, so what do we do with one molecule? We need to learn how much does it weigh? What is its mass? Okay, have time. Let's try. Come on, Vanessa, Cristina, let's go. One molecule. We are in molecule. We want to calculate the mass in grams of one molecule. We know that the molecular mass is 98 U's, no? 98 atomic mass units, but we want to calculate the mass in grams. Okay, let's go. From molecules, time is almost done. Okay, so let's go. Nobody, Cody? You had problems in the first round, in the first set of activities to calculate. One molecule we calculate the number of moles. We know that 1 mole is 6 times 23 molecules. Okay, so 1 divided 6.022 times 223. Ruben got it. Let's check it. 1.66 10 to minus 24 mole. And now from mole to grams, okay? Perfect, great job. 10 to minus 24 mole, and we know that 98 grams is 1 mole. You can do it also in one single calculation, okay? Molecule to mole and another conversion factor and another factor here. So you can save time, but if you do it like this, it's okay. Okay, times 98 equal to 1.63 10 to minus 22 grams. Maybe I had a mistake. Let me check. 1 divided 6.022 times 223. No. Be careful. Ruben, this is very. I think you got a mistake. 1.63 10 to minus 22 grams. It's okay. I think it's okay. Did you have a mistake or something wrong here? No. No, I think it's okay. Okay, so be careful. 10 to 23. Okay, be careful with the sign, okay, of this thing. I think you divided or something wrong, okay? Okay, so this is the type of problems that I call chemical calculations. One like this will be in the exam, okay? One or a couple of problems like this in the exam. Okay, number 4 is a balance. You need to balance chemical equations and read chemical equations. In this case, one molecule, or I don't know how many molecules, we're going to write and read the chemical equations. Some of them are very easy. Okay, let's say A, B, and C are really easy. Yeah, Miguel said that it's too big, no? One molecule weighs more than Guadalpeña building, and 10 to 23, 4, maybe more than Arcos itself. Okay, let's balance the chemical equations. Some of them are really easy. Let's try. Come on, equation A, really easy. CO plus CO2 equal to CO, carbon monoxide, reacts with oxygen. So what is the balance? O2 to obtain CO2. Here we have 2 oxygen, and here we have 3. So what can I do? Right, 2 here. Let me use red for corrections. 2 here. Now we have 2 oxygen, 2 carbon, and 2 here. Are you doing? This is not difficult. Letter B, the composition of potassium nitrate, nitrato de potasio. And the composition in nitrito de potasio, and oxygen. Okay, so here we have 4. What can we do? You got it very well, Maria. This one, come on, what do we do? Let's try. 3 oxygen, 4 oxygen here. So what can we do? Very easy too. So I can balance this using 3, 2, and 2. So I can balance here 2. Now we have 6 oxygen, 2 potassium, 2 nitrogen. So 4 and 2, 6 oxygen. Okay, letter B is not difficult. Letter C, ozone decomposition. Be careful, Vanessa. Be careful, Vanessa, okay? We have to. Yeah, you got it. This is really easy. Ozone decomposition, decomposition del ozono is the reaction that takes place in the ozone sphere, destruction of ozone. Very easy. You got it, Miguel. 2 and 3. Okay, let's continue with letter D. This is a little more difficult. Ammonium nitrate, nitrato de amonio, decomposing nitrogen oxide, dinitrogen oxide, and water. Okay, got it. Paula, very well. Estrella, very well. Cristina, let's go with this one. Nitrogen is okay. 2 nitrogen. Hydrogen is not so okay. This is not difficult. Okay, you got it, Vanessa. 2 water here. Very well, Paula. Now we have 2 times 4 water, 4 hydrogen, and 4 hydrogen. Letter E. This is a little more difficult. Oxygen to form CO2, water, and nitrogen. Okay, let's go. 2 nitrogen, okay, nitrogen at the end and oxygen at the end. 1 carbon, carbon is okay. But the key is hydrogen. We have 5. Here we have 2. So let's use a pencil to be ready, okay, to be sure. No, I don't have a pencil. Oh yes, I have it here. we have 5 hydrogen, and here we have 2. So what can we do? We can double. Vanessa got it very well. We can double. Then we have 10 hydrogen. We can use 5. We can now 10 hydrogen. 2 carbon. 2 carbon. 2 nitrogen is okay. And what about oxygen? We have 4 and 5, 9 oxygen. Impossible here. So we double. Okay? 4, 4, 10, and 4. So we have 4 nitrogen, 4 nitrogen, 4 carbon, 4 carbon, 20 hydrogen, 20 hydrogen, and oxygen we have 8 and 10, 18. So we write 9 here. Okay, this is interesting, this is difficult. Lo digo en español, ¿vale, chicos? Lo recuerdo, ¿vale? Para que se os quede bien. Esta, cuando me he ido a ajustar, he dejado los hidrógenos y los nitrógenos para el final. Viendo los hidrógenos que había 10, parecía que aquí llegaba con un 5 y aquí con un 2 para el carbono, ¿vale? Porque aquí había puesto un 2, pero me he dado cuenta que al final los oxígenos había que poner 9 oxígenos y no podía poner 9 oxígenos poniendo aquí un número entero. Entonces, lo que he hecho es que he doblado todas las cantidades que había puesto hasta ahora y ya sí puedo poner, porque ahora hay 18 oxígenos. ¿Vale? Este es muy interesante. Uno de este estilo pondré en el examen. Una pena que haya gastado esta en la ficha, porque me hubiera gustado para el examen. ¿Vale? Y vamos a ver la última. The last one, let's go. We have, I'm going to do it here. Chromium hydroxide. And perchloric acid. Perchloric acid. React to form chromium chlorate, no, chromium perchlorate, and water. Okay, so we have one chromium is okay. 3 and 4, 7 oxygen. 12 oxygen. Oxygen is not okay. And hydrogen, we have 3 and 1, 4. Okay, so I have here the problem with oxygen. I have 13, and here I have 7. Okay, so if I have 13 oxygen and 7, I need to touch a little bit this. Here we have 3 chlorine, and here we have 1. So one good idea would be 3 here to balance the chlorine. Now I have 3 and 3 hydrogen, so 3 water, 3 chlorine, 3 water. And how about oxygen? Now I have 3 and 12, 15. 12 and 3, 15. Okay, so that's the key. This is difficult too, okay? One like this in the exam. Very well, Cristina, Vanessa. Got it. Okay. You got it. Okay, let's continue with cuando hay paréntesis, dice Paula. Mira, cuando hay paréntesis, tienes que fijarte que el paréntesis es como cuando hay paréntesis en matemáticas. Este 3 te dice que hay 3 oxígenos y 3 hidrógenos. ¿Vale? Y este 3 de aquí te dice que hay 3 cloro y 4 por 3, 12 oxígenos. ¿Lo ves? Entonces, cuando tenga un ion y luego el paréntesis y otro número aquí, 3 por 4, 12. ¿Vale? ¿Me entiendes? Mira, por ejemplo, te voy a poner un ejemplo. ¿Cuál sería, por ejemplo? Mira, mm, esta sustancia. A ver si alguien se acuerda qué nombre recibe esta sustancia. No sé si existe de verdad, ¿eh? Pero en español, ¿cómo sería esta sustancia? ¿Alguien se atreve a formularla? Venga, ¿alguna maquinilla de la formulación? ¿Alguna maquinilla? Tenemos NH4, ¿verdad? Que dije que os lo mentalizara y que era como si se nombrara como si fuera un elemento propio, no, no es un elemento, son dos elementos, pero recibe un nombre este ion, ¿verdad? Y aquí ese es. ¿Esta qué sustancia es? Venga, a ver, ¿qué sustancia sería esta? Los lunes y los jueves también seleniuro de amonio. Correcto, ¿vale? Seleniuro de amonio. Igual que el anión seleniuro y el catión amonio, seleniuro de amonio. Venga, pues pregunto yo, ¿cuántos hidrógenos tendría? Tendría dos nitrógenos, ¿no? Dos nitrógenos. Y fíjate, aquí es donde a lo mejor Paula se lía, ¿no? Con el paréntesis. 2 por 4, 8 hidrógenos y uno de selenio. Si quisiéramos hacer la masa molar, pues 2 por 14 más 8 más uno por la masa del selenio, que no me acuerdo cuánto es. ¿La has pillado ya, Paula? Dime por ahí por el chat, sí, yo creo que sí. ¿Vale? Es que ahí es donde tenéis que tener cuidado con los paréntesis. Okay, you got it. Let's continue with number 5. Remember the ideal gas law. Okay, number 5. Ideal gas law. Say that pressure, volume. Pregunta Paula, si el selenio está delante, como el cromo, sigue teniendo uno. Claro, en la de antes, en esta fórmula, mira, en esta, un cromo, 3 por 3 cloro y 12 hidrógeno, ¿vale? Da igual que esté delante o detrás. El paréntesis lo que te dice es que hay 3 de lo que haya dentro del paréntesis. Como cada ion de esto es un cloro con 4 hidrógenos, perdón, con 4 oxígenos, pues 3 por 4, 12. 3 cloro y un cromo. ¿Vale? Ya sí, ¿no? Bueno, let's go. Ideal gas law. P, pressure and volume equal to N, T. Okay? Pressure in atmospheres. Pressure in atmosphere. And remember, another unit for pressure in chemistry is millimeters of mercury. Okay, so sometimes we need to convert volume in liters. And remember, 1 cubic meter equal to milliliter, and 1 liter equal to 1000 cubic centimeters. Okay, this is number of mole. This is the constant. Atmosphere liter divided mole Kelvin. And this is temperature in Kelvin. Remember, Kelvin, we add 273. Okay, this is what you need to do ideal gas law problem. So in activity number 5, what is the mass of 50 liters of gaseous nitrogen at 35 Celsius and 1 atmosphere? What would you do? Carrier, what would you do? How would you calculate the mass of 50 liters of gaseous nitrogen? We know the volume, 50 liters. We know the temperature, 35 Celsius. Quickly, I convert it to Kelvin. It's 308, no? 300. No, sorry. 200. No, sorry, 308. Yes. And pressure 1.5 atmosphere. 2.97 watts. Moles, grams, kilograms, liters. Okay. First, what do we do? We calculate the number of moles. Okay, you got it. We calculate the number of moles. Pressure 1.5 pressure. Okay, we go to PV divided RT. Okay, so let's try 1.5, 50, 0.082. Temperature is 308. I think you're right. So 2.97 mole. And what is the mass of nitrogen? Gaseous nitrogen is N2. So it's 2 times 40 equal to 28 grams per mole. So 2.97 mole, and then we calculate, okay, then mass, we know that 28 grams, 1 mole. So we obtain 83.16 grams. Okay, got it, very well. This is number 5. It allows gas when we have gases to convert from number of mole to volume, or from volume to moles, or from moles to volume, using the pressure and temperature conditions. Okay, is this part clear? You got it? Is this part clear? Everything understood? Can go with the final type of activities. Let's go. 6. They give you the reaction. Okay, number 6. They give you the reaction. All clear. Okay, now we know the chemical reaction. NO2 S2O3 plus silver bromide to obtain sodium bromide. What type of reaction is this? This is a displacement reaction. Na3. That's good for Paula to practice. Ag S2O3 2. Okay. Paula, in this compound, este compuesto, how many atoms of sodium? 3. Okay. How many atoms of silver? 1. Okay, this is no number here, so 1 silver. How many atoms of sulfur? 2 times 2, 4 atoms of sulfur. And how many atoms of oxygen? 3 times 2, 6 atoms of oxygen. Let's try to balance the equation. First of all, let's try to balance the equation. Okay, here we have sodium, we have 2, and here we have 1 and 3. So what about a 2 here? Okay, got it. I think you got it, Paula. Now 2. Sodium is okay. 2 times 2, 4. Sulfur is okay. And 2 times 3, 6. Oxygen is okay. I like it. Silver is okay. 1 silver, 1 silver. And bromide is okay. Okay, so now it's adjusted with these 2 here. Given how many moles of N2SO2O3? Asking mole are needed to react completely with 42.7 grams of bromide, silver bromide. 42.7 grams of Ag bromide. Okay, let's go. Oops, you don't see the, okay. They give you the reaction, how many moles are needed to react to completely with silver bromide. We need to know the weight of silver and the weight of bromide. Silver, I look in the table. Silver is 87. And bromide is 79.90. 90 U. So let's go. Now we know that silver bromide weight 1 mole of silver bromide weight, we do the addition, 107.97 plus 79.9 equal to 187.8 grams per mole. Okay, so let's go. Let's calculate how many moles of this substance, sodium disulfate, sodium disulfate would we need it, or it could be needed. Anyone? Ok, ¿cómo calculamos esta cantidad, los moles de disulfato de sodio que necesitamos para reaccionar con 42,7 gramos de bromuro de plata, silver bromide? Venga, in English this is bromine, the element, and bromide, bromuro, bromide with D. Silver bromide. And this is bromine. Bromine is the element. What will we do first? First, what do we do after adjusting? What do we calculate first? ¿Qué calculamos primero? What do we calculate first? Come on. Any idea? Any question? We calculate the moles of silver bromide. Okay, let's go. We have 42.7 grams Okay, got it. 187.8 grams per 1 mole equal to as estrella C 0.22 mole of silver bromide. And then we use the molar proportion. We could say like this. So 2 moles react with 1 mole. 2 moles with 1 mole. So we have 0.22. So how many moles are going to react? We can use the proportion 0.22 mole of silver bromide. It's a little, and 2 moles with 1 mole. So it's double, 0.44 mole of N2S to O3. Okay? So we have double. 2 moles react with 1 mole. 2 molecules react with 1 molecule. Okay, Paula Gori. So next day, today is time to finish, okay? Number 6 is also how many mole, what is the mass of bromine sodium that will be producing. You can try, and next Thursday we explain, we solve, we correct these activities. You don't need to send it by mail, okay? You have sent a lot of activities last day, so you can try at home, or if you understand, you can try next Thursday with me. So if you think that you are very lost, si creéis que estáis muy perdidos, que no lo domináis, os recomiendo que lo intentéis. No tenéis que enviármela, ¿vale? Las intentáis hacer y en las correcciones pues aprovecháis mejor, os va a dar más seguridad. Los que lo dominéis, que creéis que lo lleváis bien porque ya lo habéis entendido, han salido bien todos los ejercicios de la primera vuelta, pues simplemente el jueves echarle un vistacillo a la clase, ¿no? Lo resolvemos aquí y simplemente afianzamos, ¿vale? Entonces un poquito de adaptación y de todos los niveles. Quien lo lleve regular, eso, que lo intente hacer, que lo haga y que lo pruebe, que se ponga un poquito a hacerlo y aproveche el tiempo. Quien lo sepa hacer bien, pues en principio el jueves van a ser las correcciones de los que quedan, ¿vale? Y para ir bien preparados para el examen del lunes. Okay, so everything's clear. Any doubt? I left this problem in last page, okay? Any doubt? Do you understand? Do you feel more confident? ¿Sentís que tenéis más confianza, more confident? It's okay. Any question? Any question? No question? Okay, so bye-bye. Have fun this week. And see you all clear, Ruben? Got it? Okay, so I think for you, Ruben, and other people, Maria, that understand, it's enough you to take a review next Thursday, okay, and the weekend before the exam. But if you have difficulties, try to practice a bit more. Okay, Estrella, no problem. That's great. That's great. Okay. So we'll meet on Thursday at 11:40. Have a nice week. See you.